What do we mean by GCFs? So GCFs, or greatest common factors, they play a very big role in mathematics. In order to reduce functions or fractions, we need to find GCFs. How do we go about finding the greatest common factors? First, let us understand what is a factor. So factor of a number are the numbers that divide the original number evenly. These are factors. Then what are common factors? So a number that is a factor of two or more numbers is a common factor of those numbers. And now what is a greatest common factor, or what are greatest common factors? So GCF is the largest common factor of two or more numbers. For instance, the factor of 24 are 1, 2, 3, 4, 6, 8, 12, 24. Why? You take any number, say 6. So 24 divided by 6, the remainder will be 0. That means these numbers divide 24 perfectly. The factors of 36, all these numbers, they divide 36 perfectly. Let us take example 1. Let us take any one of these, say 18. So 18 twos are 36, right? So 18 twos are 36. You get remainder as 0. So this is remainder. I'm talking about remainder here. The answer will be 2. Here answer will be 4, but remainder is 0. So the common factors of 24 and 36 are what? These are, just take the common factors, 1, 2, 3, 4, 6 and 12. So the greatest common factor of among these of 24 and 36, this is the greatest one, so this is the GCF. So how do we write it? Let us just see how do we write it. We write GCF of say x, y is some z number. So we write like this. Here in this case, we have 24, 36, this is equal to 12. So how do we find the GCF? We can find the GCF of two or more numbers by listing out the factors of each and then identifying the largest common factor. This we can do. But this could be difficult when the numbers are very large. This will not be feasible. So we have to have some systematic approach to finding the GCFs. How do we do that? We will find the GCF of two or more number using the prime factorization of each number and using a process nearly identical to what we have done in finding the LCMs of two or more numbers. So let us see. First of all, 24, let us take the prime factorization. So 2 into 12 is 24. So 2 12s are 24. So 2 6 are 12. So you get 2 and 6. Then we have 2 3s are 6. So you get 2 and 3. And then finally 3 1s are 3. Like this. So what do you get? 2 2 2 3. 2 2 2 3 are the factors of 24. In the similar way, 40 is 2 20s are 40, then 2 10s are 20, then 2 5s are 10. So you have 2 2 2 5 as the number 40's prime factors. So how do we go about finding GCFs? So 24 was actually 2 2 2 3, 40 was 2 2 2 5. These were the prime factorization. Now we have to arrange the factorization in a table. How do we write the table? So these are the primes, that is we have 2 3 5, and then we have for 24 we have 2 cube, that is 2 cube, 3 to the power 1 and 5 to the power 0. In the similar case, if it write 40, then you see we have 2 to the power 3, so we write 2 to the power 3 here, and then we have no 3, so 3 to the power 0, and we have just 1 5 here, so we write 5 to the power 1. So this becomes factors are 2 to the power 3, 3 to the power 0 and 5 to the power 1. So what is the GCF? GCF, we circle the smallest product in each column. So what is the smallest product? These two are same, so it is 8. 1 and 0, which is the smallest? So 3 to the power 0, that is 1. Which is the smallest? 5 to the power 0, which is 1. So 8, 1, 1. Now we multiply them. So we have circled the smallest product in each column. The GCF of 24 and 80 will be 8 into 1 into 1, that is 8. The exponent, that is 2 to the power 3, or like this, represent the number of number of times that factor appears in prime factorization. In the prime factorization of the numbers, we can find the prime factorization of the GCF. So 24 40 is 8. This is nothing but 2 cube. So this 24 is nothing but 2 cube into 8. So you can have 8 here. This is 2 cube. And in place of in the 40, you see this 2 into 2 into 2, that is this one, is again 8. This is 8. This is 8. So 8 is a factor of both 24 and 40. So it divides 24 and 40 entirely. Let us take one more example, 32 and 51. We have to find out the GCFs. GCF, how to find? First, we'll find the prime factorization. So 2 16s are 32, then we have 2 8s are 16, then we have 2 4s are 8, then we have 2 2s are 4, and then 2 1s are 2. So we write all these 2 2 2 2 2. So this is nothing but 2 to the power 5. Here we have 15, so we start with 3. It will not be divided by 2, so we start by 3. So we get 17. Now 17 is a prime, so we are left with only 3 and 17. So 51 can be written as 3 into 17. Here we have 32 as 2 to the power 5, that is 2 2 2 2 2 5 times, and then we have 3 into 17. Now find the common factors. What is the common factor between them? There is no common factor. There is nothing common, so only one is the common. So we multiply all the factors which are common together, which is only 1. So we have GCM or GCF, you should say. Sometimes they are calling it as GCD also, greatest common divisor. So these both are same. So GCF and GCD are same. Let us take one more example, 102 and 84. Now 102, 251s are 102, 3, 17, and these 2, 3 and 17 we are left with. So we have 32 as 2, 3 and 17. These are the prime factors. Again we go about 84 to find the prime factorization. So 2 into 42 and 2 into 21 and then 3 into 7. So then 7 into 1. So we get 2, 2, 2, 2, 3, 7. So we have 2, 2, 3, 7. And now what we have to do? We have to find out the common factors. So this 2 is common, then we have 3 as common. So 2 into 3. These are the common factors. 3 into 6, but we have to multiply the common factors together. So 6 is the GCF or GCD of 102 and 84. So let us take 3 numbers now, 14, 42, 84. Let us find the prime factorization first. So 2 7s are 14 and 2 and 7 are the prime factors. 42, 2 21s are, then 3 7s are, so 2, 3 and 7 are the prime factors. Then 84, we have already done that. So 2 42, 2 into 21 is 42, 3 into 7 is 21. So 2 2 3, 7 ones are 7, so 3 7 also. So now we will find out the common ones. What are the common? 2 is common, so just cancel them. Just cancel them and write it here. Then we have 7 cancel them and just write it here. Rest you don't have to check because it's already over. So 2 into 7 is 14. 14 is the we multiply all the common factors. 14 is the actually GCD or GCF of these 3 numbers. So GCD is 14, 42 and 84 is 14. So this is about the greatest common factor or greatest common divisor. Thank you so much. Take care of yourself.